Hey guys, so far in this unit we've taken a look at direct and inverse variation equations. Those are the equations that would model the growth or the decay of a variable based on another variable. Well, obviously a picture is worth 1,000 words, and each one of those functions has a picture that goes along with it. So today we're going to start off by taking a look at the properties of the graph of the direct variation equation y equals k times x. So before we get going, a little bit of terminology here. The graph of y equals k times x is simply the graph of the direct variation equation, and it is the set of all relations x, y that form a line passing through the origin 0, 0 with a slope of k. So those are a couple of properties there for you that you should take note of right away. All direct variation equations will pass through the origin of the coordinate plane, that's the 0, 0. They are going to have a slope of k, and they're going to be linear. All right, let's talk about slope a little bit. Slope is the steepness of a line. It's also known as the rate of change. So you'll hear us commonly refer to the slope as the rate of change. It can be expressed as the fraction of rise over run, or another way of saying that is the change in the y-coordinate over the change in the x-coordinate. Now there is a specific slope formula that goes along with calculating the slope of a line, and it goes like this. M is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So that is when you have the coordinates x1, y1 and x2, y2 that lie on that line, you can find the slope between those 2 points by taking the difference in the y values and dividing it by the difference in the x values. All right, we're going to take a look at a Desmos sketch now, and I'm going to pull that up on the screen here in just a second. And from that Desmos sketch, we're going to see a dynamic version of this direct variation equation y equals k times x. We're going to be able to slide the value of k and change it, and then we're going to be able to answer these questions as we drag that value around. So let me pull that up now. Here we go. Here is the equation y equals kx, or k times x. And you can see here that we have a slider for the value of k. So if we start off with k at 0, we really would have y equals 0 times x. Well, that's just the line y equals 0. And you can see that that is a horizontal line, which is just the x-axis. As we get positive here, you can see the steepness of that line starting to increase. Here's the value where k is 1. That would be y equals 1 times x, or y equals x. And that's that 45-degree line, that line y equals x, where all the points on that line have the same x and y values. All right, as we keep dragging it larger and larger in the positive direction, you'll notice that that line gets steeper and steeper, and it also gets closer to the y-axis. But it never crosses over that y-axis. As it gets lower and lower, but still remains positive, it gets closer to the x-axis and a lot less steep. As we get into the negative values, what happens is the slope of that line tends to be down towards the right rather than up towards the right when it was positive. So when we have a negative constant of variation, a negative k value, you can see that my slope gets, slopes down and to the right. And as it gets larger and larger, again it approaches that y-axis. All right, let's go back to our notes here and see if we can answer a few of these questions. What happened to the slope of the graph as the k value became positive and larger? Well, as k grew towards 10, we noticed that it was a steeper slope. We noticed that the line came close to the y-axis. The line grew towards the y-axis. Oops, let's see if I can spell towards right here. And our line got steeper, the line grew towards the y-axis. Yeah, those are a good little summary here. And what happens to the slope as the k value became positive and smaller? Well, now it was going to become less steep of a line, and our line grew towards the x-axis. Now, in both of these cases, we had a positive slope. So remember, for positive slopes, they both went up to the right. All right. However, we can see the difference here. What happens to the slope of the graph as the k value became negative? Now our line went down towards the right. All right. The next is to manipulate the graph by changing the slider and answering these following questions. For what value of k gives you a horizontal line? Well, if you remember, we took a look at that right away. We said when k was equal to 0, it actually gave us the equation y equals 0. And this was the horizontal line, also known as the x-axis. For what value of k's will your line slope down into the right? So if we don't remember what that might look like, we can just kind of draw that picture here again. Here is a direct variation equation. Remember, it has to pass through that origin, and it's going to slope down and to the right. This meant that our constant of variation must have been negative. All right, example 2 now asks us to calculate the slope of the line which contains these points, 10, 7, and 8, 1. So I'm just going to label these x1, y1, x2, y2. And remember my slope formula, which said to take the difference in the y's, y2 minus y1, and divide it by the difference in the x's. All right, so I'm going to simply follow that formula. It says 1 minus 7, divide that by 8 minus 10. That's going to give me negative 6 over negative 2. A negative divided by negative will result in a positive. That'll be 3 over 1, which I can simplify to just 3. So here is my rate of change between these 2 points, 10, 7 and 8, 1. In example 3, I'm asked to find the slope of the direct variation equation. Here it is, d equals 5/7 w. Well, remember, our constant of variation is always equal to our slope in a direct variation equation with degree 1, or with power of 1. And therefore, my constant of variation here is 5/7, and 5/7 is my slope. All right, example 4 asks us to grab our graphing calculator. So take a second to grab your graphing calculator. Okay, you can see that I've pulled up my graphing calculator. We are going to go to our y equals, and we are going to enter the simple direct variation equation y equals 1.5x. So we're going to hit 1.5x. The variable button here is right next to your alpha key. Press X. And now we're going to go to our table of values. We're going to hit second function, graph, and that's going to take us to our table. If we scroll up here, we can see where x is equal to -4, y is equal to -6. So I'm going to take a second to fill that in on my notes. Also at -2, I see that I'm at -3. At 0, this should be 0. +2, it should be +3, and 4 should be +6. And if I don't remember, I can just go back and pull up my calculator here and cursor down to make sure all of those are the correct values. Lastly here, we wanted to graph this direct variation equation. Once we have these points here, we can plot those points on our xy plane. So 0, 0. And if we go to 2 over and 3 up, once we plot all those points, then we can draw a line through all those, and you should see that it is a linear function. A straight line will connect all of those points, and it should pass through the origin. In this case here, our slope is 1.5, and you can see that that is pointing up and to the right. All right, our final example for today says the solid bold line at the right is graphed. It represents the equation y equals 1x, or y equals x. Determine which of the dashed lines matches each of the given equations. So this question here is really just getting after whether you understand steepness of slopes. So here is y equals +5x, y equals -5x, y equals +1/5x, y equals -1/5x. All right, so I'm going to start off with my positive slopes. Those are the ones that come up and to the right. My ones with negative slopes go down and to the right. So things that end up here in quadrant 1 of my coordinate plane will be positive. The one that's more steep is 4. So I know y equals 5x must be the graph of this dotted line 4. And that leaves 2, the other one here, to be the graph of y equals 1/5 x. Next are my 2 negative slopes. The more steep one here is going to be 3. And then my less steep one here, or the one that's closer to 0, would be -1/5 x, and that is going to be my graph here of 1.